These three problems are all very similar to the 2-6 free response that you studied over last weekend. So if you look here, I've given you a function that involves a rational expression. So we have a factorable polynomial on top, a factorable polynomial on the bottom, same with each of these, and based on that we need to determine whether or not we have a horizontal asymptote and what it is. We need to determine whether or not we have a vertical asymptote and what it is, and we need to identify holes, x-intercepts, y-intercepts, and then draw the picture. In all three of these, calculators are not allowed. So I'm going to start with just number 4, and then we'll kind of systematically work through all three of them. Okay, the first thing that we need to do is we need to factor, because we can't identify x-intercepts and y-intercepts and holes and vertical asymptotes. We can't get any of that unless we have factored. So down at the bottom, I'm going to write that f of x equals, and hopefully, let me scoot this up just a little. I want to make sure you can see it. We'll get f of x equals an x minus a 3 times a 3x plus a 2. And on the bottom, we'll have that same x minus 3 and a 2x plus 1. Now, once it's factored, that enables us to find vertical asymptotes, x-coordinates of holes, and x-intercepts. So to find vertical asymptotes, let's remember that we're looking for numbers that are not 0 over 0. So we need values of x that will create a 0 on the bottom that is not a 0 on the top. So we can see that this 3 that makes a 0 with the x minus 3 factor is also a 0 on the top. So that's not going to be a vertical asymptote. That's going to be the location of a hole. So we can put 3 is the x-coordinate of the hole. The vertical asymptote will occur at x equals negative 1/2. So we can come up here and say x equals negative 1/2 will be a vertical asymptote. And if we look at the rubric, we see that I don't have to put any justification, so I don't need to write a limit statement that will verify that. I will probably use limits to help me with the graph, but right now I'm not going to write that down. The next thing we need is the x-intercepts. Now remember, x-intercepts are the zeros. Those are the places where you cross the x-axis, and it's when y equals 0. So if we come up here, the y coordinates are the same as f of x. So we have written f of x as a fraction. Well, fractions only equal 0 when the top equals 0. So if I come down here, we can see that the top equals 0 at 3 and at negative 2/3. However, at 3, we did not have a domain element because we were trying to divide by 0. So 3 is not even in the domain, which means we cannot possibly have an output of 0 when we can't even plug in 3. So that means our only x-intercept is going to occur at x equals negative 2/3. And in my rubric, I chose to write that x-intercept as an ordered pair. The y-intercept is what happens when x equals 0. So if I take an x equals 0 and I plug it into the function, then everything over here that has an x in it is going to turn into 0. So we can essentially cover this up and see that we'll be left with a negative 6 over negative 3, which is a positive 2. The next thing that we have to look at is the horizontal asymptote. The horizontal asymptote, if you recall, comes from looking at limits of that function f of x as x gets really big in either direction. So that means we will be looking at dominant terms. On the top, it is the 3x squared that grows the fastest. On the bottom, it is the 2x squared that grows the fastest. So if I reduce that, I get a limit of 3/2. That means y equals 3/2 is one horizontal asymptote. Now if I also look on the left-hand side, because I have no exponentials or absolute values or anything that's going to make this curve have dominant terms that are different on the left, I'm going to have the exact same limit set up. So I can go to positive infinity or to negative infinity, and I'm still going to get that same limit. So I've only got one horizontal asymptote where y equals 3/2. So now the last thing that we need to look at is, well, I shouldn't say the last. The next to last is the y coordinate of this whole. We want to assign points to both the whole thing. We can't just put the x coordinate. We need to have the y coordinate. So if we remember, the y coordinate of the whole is the location on the graph where if you hop on the curve on both sides, it's the y coordinate your thumbs will get close to as you move closer and closer to 3. So that means to figure out what the whole is, we need to look at the limit of this down here as x approaches 3. And in order to compute it, I'm going to scoot for just a minute here. In order to compute it, we're going to cancel out the x minus 3's. That would give me a 3x plus 2 over a 2x plus 1. Now 3 is no longer a problem, so I plug it in and I'll get 11 over 7. So the y coordinate of the whole is 11/7. So now our final points, 2 of them are going to come from the graph. On the graph, I'm going to be looking for the horizontal asymptote, y equals 3/2. I'm also going to be looking for the vertical asymptote, x equals -1/2. I'm going to be looking for the whole, which is 3 and 11/7. So 11/7 is just a little bit bigger than this what did I graph here? My horizontal asymptote of 3/2. It's a little bit bigger than that. So I'm going to put a circle that's open, because that's a hole, a little bit above that asymptote. And then I've got some zeros that I can put on. I've got a -2/3, which is further left than my 1/2 here. And I think I have everything on here. Oh, nope, I've got a y-intercept, which is 0,2. Okay, so now our job is to connect everything. Since I have a point and a hole kind of in this quadrant, chances are very good that I'm going to connect those so that we look like this. And since this point is in the quadrant kind of delineated by these asymptotes, I'm going to stay within those asymptotes and get the other branch. So let's say you have a hard time figuring out whether you connect these and go down or connect. You just have a hard time seeing what's going on with the asymptotes. Well, one thing that you can do is you can look at the limit of your function as you're approaching that -1/2 from both sides. So if we ignore the x minus 3's and look, say, at here, and I'm approaching -1/2 from the right, then this number is going to be a little bit bigger than 1, so I'll add it and get positive, add 3/2 plus 2, it'll still be positive. So that means as I'm coming toward this half from the right-hand side, I will have to head up to positive infinity. By the same token, if I look at the limit of this expression as x approaches that asymptote from the left, say a number a little bit smaller than -1/2, then this bottom term will end up being a negative value, which means I will head down because the top will still be negative, or excuse me, positive. So let's try and apply this same process to B. If I look at B, again, I know I'm going to have to factor the top and the bottom because that'll help me find some of the things that I need. So I sometimes will use the non-factored form if I'm looking for horizontal asymptotes and I need dominant terms, but then other times I'm going to be looking at the factored form. So I need to have both of them. I can pull out a 3 and I'm left with the difference of squares. So I can factor like this. Horizontal asymptotes, if you recall, that's the limit as x approaches either positive infinity or negative infinity. And in this case, since there are no absolute values, no exponentials, dominant term over dominant term is going to be the same regardless. So dominant term on the top is x, dominant term on the bottom is 3x squared. So the overall result is going to be the limit of something that is growing slower than something that is growing faster. So the faster will dominate, which means the bottom will get much larger, much faster than the top. So that overall limit will be 0, which means that y equals 0 is my horizontal asymptote. Vertical asymptotes come from numbers divided by 0. So numbers that are not 0 divided by zeros. So if we look at our factored form here, we can see that 2 and -2 will both generate zeros on the bottom and not zeros on the top. So we get 2 vertical asymptotes in this case, one at +2 and one at -2. Next, the hole. Holes are zeros that occur in the bottom that also occur in the top. And in this case, we can see there are none. So no holes to worry about. The x-intercepts occur when the top of the fraction equals 0 and we're in the domain. So if I look at the top of this fraction, we can see that a value of x equals 0 will give me an output of 0. So I'll have a point at 0, 0. I can just graph that right now if I want. Y-intercepts means that I will plug 0 into the function. So if I plug 0 into the function, I end up with a 0 over a -12, which is a 0. So I can write my x-intercept as 0, 0, and my y-intercept is also 0, 0. What this tells me is that the graph cannot cross the y-axis ever again, nor can it cross the x-axis ever again. So that might help us when we're trying to graph the picture now. Given that y equals 0 is a horizontal asymptote and x equals -2 is a vertical asymptote and x equals +2 is a vertical asymptote. So here we've got all the information that's in our little chart here, and we still don't know what's going on with the graph. We don't know whether we'll graph in this section or in this one. We don't know whether this is going to start up and then go down, or vice versa, or maybe the whole thing will be above and the whole thing will be below. We don't know whether we're in this section or this section. So this is where our old Algebra 1 techniques can help us. We can simply plug some points in and see what comes out. If I plug in a 1, I'm going to get a 1 over a 3 minus a 12. Well, that's a 1 over a -9. So that means when I plugged in a 1, I got a -1/9. So it's going to be below the x-axis. If I plug in a -1, I will get a negative on top, and I will get that same -9 on the bottom. So in this case, I ended up with a +1/9. So these 3 points alone tell me that I've got to head up on this side and I've got to head down on this side. I have no other options because I'm not allowed to cross the x-axis, and as I get closer to that asymptote, I have to head in either a +infinity or a -infinity direction. So now let's check what happens over here. If I'm at 3 and I plug 3 in, I'll get a 3 over a 27 minus a 12. We can tell that that's going to be a positive number. So when I'm at 3, I got some sort of positive value. Well, because I can't cross the x-axis again, that means I am going to stay above that asymptote the rest of the time. Same with this. I know as I get closer and closer to 2, I'm going to have to head up, because if I headed down, then there would be another x-intercept, and we only had one x-intercept at 0, 0. If I do that same reasoning over here, plug in a -3, a -3 over a 27 minus 12, that's going to be a negative value that's got a pretty small magnitude. So again, same argument. I can't cross the x-axis again, so I'm stuck in the region that is delineated by these asymptotes.